Hey guys, Ms. Davis here. This is Unit 6 Skill 9 video, Remainder Theorem. So how can the remainder theorem help us determine if an expression is a factor, which means divides into it evenly, of a function? So here we go. We're going to start off with a polynomial. Function below, evaluate the polynomial for the given value of x and divide the polynomial by the given factor. So we've learned earlier in our notes and in this unit how to divide a polynomial by a factor. So example 1 says, if f of x is this, find f of negative 4 and determine the remainder, so we want r equals a number, if f of x is divided by x plus 4. So the first thing we're going to do, I'm going to kind of show you the long way, which would be what you would need to do if it was an algebraic answer, so meaning you need to provide all of your work. So we're going to first set this up as a long division problem, just like you've learned earlier. So big long division line, and our we're going to put this on the outside. So that's what it's being divided by. And now our polynomial, we want to write our write it in here underneath, but we want to make sure we leave room, because see how there's a missing 4 and then it goes down to 2. We're missing an exponent of 3. So it's very important that you write it as point plus 0x to the third if there's not one there, because there needs to be some sort of placeholder there to continue with the long division. So minus 14x squared plus 5x minus 3. All right, so the first thing we want to do as a refresher is to take our first term, x, and see how many times or what you would need to multiply it by to get back x to the fourth. So x to the first times x to the third would give us back x to the fourth. So now we're going to take this term up top and we're going to multiply it back, kind of distribute back to those terms there and write what we have left over underneath. So we've got x to the third times x to the first would give us back, would give us back x to the fourth. And then x to the third times 4 would be plus 4x to the third. Okay, and then we would subtract, and we would get those guys to cancel out, which is the goal. And then we would have minus, so 0x to the third minus 4x to the third would be negative 4x to the third. All right, now next up is to carry down just the next term, so negative 14x squared. And we want to take our same x to the first and see how many times, or what we would need to divide, or sorry, multiply it by to get back to negative 4x to the third. Well, if we take x to the first and we multiply it by a negative 4x squared, if we multiply that times this guy over here, that would give us back that negative 4x to the third. So it would make it match there. Okay, and then we're going to do the negative 4x to the second power times 4, just the 4 in the outside divisor. So when we multiply, we get negative 16x squared. All right, now when we subtract here, when you subtract both of these things, these both actually turn into positive. So this turns a positive, and then subtracting another one there would also make that positive. So negative 4x, those cancel out. And then we have a positive 2x squared here. Bring down our next term, so plus 5x. All right, so how many times does this x divide, divide into 2x squared? Would be, we need a 2, so plus a 2. And if it's x to the first times x squared, we need one more x to make 2x squared. So when I multiply that back through, I get 2x squared. And then 2x times the 4 here would give us plus 8x. All right, we're subtracting to go downward here. So we're going to subtract that and make sure we carry over a negative there. So we really have 5x minus 8x is going to be negative 3x. Okay, and then our last step is to bring down that minus 3, or that negative 3. And we're going to take the, again, x, and to get a negative 3x, we need just a negative 3. So negative 3 times x is negative 3x, and then negative 3 times 4 will give us negative 12. All right, now again, we're subtracting this whole thing. So by doing that, these turn positive, and another negative turns positive there. So when I add down, I end up with those canceling, and I get a positive 9. So this right here is the remainder, okay? So it has a remainder of 9. So that's the first way that I'm going to show you how to do this problem, and that is the remainder, so we're answering the question here. Remainder is 9, but now step 2 is we're just going to take, if we have a binomial here of x plus 4, a factor, that means that when you solve it for 0, it turns into x equals negative 4. So we switch the sign. So what we want to do is we want to find f of negative 4 by plugging in negative 4 into our original polynomial. So I'm going to do f of negative 4. Now you would write it out as parentheses negative 4 to the 4th power minus 14 parentheses negative 4 squared, sorry about that, plus 5 parentheses negative 4 minus 3. Okay? And if we type that whole thing into the calculator just as we see it, we're going to end up with f of negative 4 equaling, it ends up becoming a positive 9. Okay, so now this right here is the same thing, or shows the same thing as the remainder of 9. So when you plug in the root of the factor in parentheses, it gives you the same number as the remainder. It gives you the actual remainder. Now I'm going to insert a video really quick to avoid any sign errors here. I'm going to show you how to store a variable. So I'm going to write, we're going to store x as negative 4, because the most common mistake is students making sign errors, and this is just a silly mistake to make. So to get this right every single time, I'm going to insert a video now to show you that. So what you need to do in order to store a variable in the calculator as a number, go ahead and go to your calculate screen. So make sure you go through these steps with me. You're going to type in the number that you want stored. So for example 1, we want negative 4 stored as a variable. And then see the button right here where it says STO right above the var key. You're going to hit Control var. That little arrow is going to pop up. And let's say we want to store it as X. So we're going to type in the letter X and hit enter. So once you hit enter, it has now stored. Anytime you type in an X, it's going to treat it as a negative 4. So now for example 1, we want to just type in what we have for the actual example. So the polynomial given was x to the 4th power. So type this in, minus 14x squared plus 5x minus 3. So type it in just as you have it on your paper and hit enter, and it'll automatically compute for you what the value of that expression is when x is negative 4. So it avoids some errors when you plug in negative. Sometimes students forget to put parentheses around certain things, which then throws off their answer completely. Okay, so off to the side, just jot down some notes on, or the steps on how to store a number as a variable. Step 1, type in the number on your calculate screen. Step 2, hit Control, then the arrow, then var, and the little arrow will pop up. Step 3, type in the letter that you want as the variable, and then make sure you hit enter at the end. Okay, so let's keep cruising here. So the remainder theorem is right here, and it says when we divide a polynomial f of x, so any given polynomial, by x minus c, so this means the opposite sign of when you plug in the number and get a remainder r, then we're going to get f of c, so whatever the number is, the opposite sign of what's given in the polynomial, or in the binomial, sorry, f of c is going to equal your remainder. Okay, so you'll get your remainder out. So example number 2 deals with a graphic example, and we are also going to do it using the store variable way, just as a shortcut, just to make sure you know how to do it, regardless of the format. So here we go. Given the function, here it is, and then here's the graph of it. What is the remainder when it is divided by x plus 1? So when it's x plus 1, the first thing we want to do is change it to its root. So if it's x plus 1 as a factor, it becomes x equals negative 1. So then we want to find negative 1 on the graph. So negative 1 is right here, and go down to where it meets the curve. So it meets the curve at negative 4. So then this point right here is the point negative 1, negative 4. That's your x, that's your y value, and your answer is just the y value. So it'll just be your output when your x is negative 1. Okay, so that is graphically, but if you do it by hand or do it using the store key, then we're going to type in the negative 1 after you've changed it to x equals. So type in, or you would show your work by doing negative 1. We're plugging it into the original function, which is right here. So x to the 3rd, or negative 1 to the 3rd, minus 5, parentheses negative 1 squared, minus negative 4, oh, negative 1, sorry, plus 1. Oopsies. Okay, so now do you see how there could be some sign errors here if you forget to use parentheses? So I'm going to show you one more time how to type this into the graphing calculator, or sorry, into the calculator to store the variable. So for the next example, example 2 in your notes, we want to store -1 as x. So let's just run through these steps one more time. So make sure you have your calculator open, or if you don't, just make sure you're really paying attention. If you don't have a calculator with you, type in the number that you want stored, so -1. We want to control var to store it as, in this case, our function still has x's in it, so we could technically store it as any variable that we want, but our polynomial given, or equation given, it actually has x in it. So now type in the original function given, so x to the third minus 5x squared minus x plus 1. All right, then hit enter, and we get -4. Okay, so nice, quick, and easy way to make sure that you don't get it wrong when you plug it in. So as you can see from the video, if you plug in -1, then the output is -4, which should match the y value there. So your remainder is -4. Okay. All right, so for the second example, what is the remainder when divided by x minus 5? So again, we want to switch it to x equals, change the sign, and we want to go to the graph when x is +5 on the x-axis, so follow the x-axis over to +5, and go down to meet the curve. Now I know you can't really tell from, it's kind of looking like it's overlapping a lot there, but it actually hits perfectly at the point -4 on the y-axis. So our point of intersection is over 5, down 4, and our y value is the remainder. Okay, so that's option 1 using the graphic way, or if we want to do it algebraically, we got to plug in the root. So when we set it equal to x, we're going to plug it into our original polynomial, so 5 to the third minus 5 squared minus 5 plus 1. And if we plug that all in, or use the store variable in our calculator, we end up with -4. Okay, again, that should match, so the remainder is -4. I'm going to pause the video and write some steps off to the side that kind of summarize these two options. All right, so go ahead and write down these steps. So you have two options. The first one is graphically. You want to switch to x equals a number, or whatever the number given here. For this one was -1. And then find the point on the graph, and the y value is the remainder. Or option 2 is algebraically, so switch again to x equals the number, plug into the equation, or use the store variable feature on the calculator to avoid mistakes. All right, go ahead and flip over to the next page. All right, before we go into example 3, I made up an example off to the right that kind of just goes through a common example that you already know. So if 4 divides into, well, we all know that 4 divides into 24 evenly, and 4 divided into 24 is 6. But if we actually did it the long division way, then we would do 4 times 6 would give us 24, and we would have a remainder of 0. So if we have a remainder of 0, then 4 is a factor of 24. And so only numbers that divide in evenly and are nice have a remainder of 0 are factors of the original bigger number. So for example 3, if it says which binomial is a factor of the larger polynomial there, then all we have to do is plug in the x equals number into the polynomial, and if we get 0 as a remainder, then it is a factor. Okay, so step 1 is we're going to convert these all to x equals the opposite number for all their roots, and we're going to go ahead and, so this is step 1, change them all to x equals, and then step 2, you're going to plug in each of them. Okay, so I'm going to pause the video and show the algebraic work on how you would plug them all in. Okay, so step 2, I've plugged all the x values in for each x value in the polynomial. You would use the store function on your calculator to do each of these. And the one that we're looking for, if it's a factor, then that means that the remainder must equal 0. So the remainder must equal 0. So if you look, the only one that has a remainder of 0 is when x is equal to +2. So that makes x minus 2 a factor of the polynomial. Okay, so off to the side, I'm going to write down some steps. Okay, so some steps over here. So for a binomial is a two term expression separated by addition or subtraction. Step 1, change. So step 1 is going to match with step 1 over here. Change to x equals a number. Step 2 is to plug in to the equation the number. And then step 3 is to determine. So you have to determine if the equation equals 0, then it is a factor. So this is very important. I'm going to kind of bubble this one in. If equation equals 0, it is a factor. If it does not equal 0, then it is not a factor. Okay? So make sure you know this. This is the big remainder theorem. Like the big point of it is to determine if it is a factor or not, if the remainder equals 0. Okay, so the last example down here, or last two down here, I'm going to scroll down. So example 4, when g of x is divided by x plus 4, the remainder is 0. So if that's true, then that means that x plus 4, if the remainder is 0, is a factor. So they're telling you that it is a factor, which implies then, and which means that x equals negative 4, the opposite sign, root, is a root. Is a root for the function. Okay, so then which of the conclusion is true, or which conclusion is true? So we're looking, if we plug in negative 4 into the equation down here into our polynomial, then we're going to get out a 0. So f of negative 4, if you plug it in, is going to equal 0, which is exactly, oh sorry, it should be g of x, but should be exactly what number 2 says, okay? Because x equals negative 4 is a root. All right. So then example 5 is continuing with this theorem. If r of x is this, then find the value of r of 2. So we're going to plug in r of 2. So we're going to do 2 to the third minus 4 times 2 squared. Okay, so after we plug this all in, we get that r of 2 is equal to negative 6. Okay, what does your answer tell you about x minus 2 as a factor of r of x? Well, is or is it not a factor? And we have to explain. So x minus 2, if it doesn't equal 0 here, then it is not a factor. So is not a factor. Of r of x, so of the polynomial given, because when x equals 2 is plugged in, it's equal to negative 6 if it were a factor. So if it was indeed a factor, then r of 2 should equal 0. And it does not. Okay? All right, that's it. Go ahead, write your summary, do your practice problems, and good luck.